Geometry, I'm back. Did you miss me? Okay, we're going to continue on with our series on writing proofs. Last time I talked to you about why we would write proofs, and today I want to just do the very first baby step in we're just going to stick our little, oh, this might not my toe, but you get the idea, my toe in the water, okay? In college, they call the introductory class of something, usually they call it like, chemistry 101 or geology 101. So this is going to be writing proofs 101, okay? And then we'll just do baby steps from there on, and hopefully by the end of this process, you'll feel comfortable in writing proofs. So the first step we're going to do is we're going to talk about how you do it, and I'm going to choose some algebra problems because you're already familiar with algebra, and I think you've already kind of, when I show you an algebra problem, you already kind of know the steps to go through. Now you just need to start adding some reasons to those. And your reasons are almost always going to be the properties that you've already learned. I think none of these are new. I wrote them up here just ahead of time because my handwriting is so bad it takes me a while to write. You know, you've heard of the addition property of equality. If you have an equation, you can add the same thing to both sides of the equation and you still have an equation. The subtraction property of equality, the multiplication property of equality, the division property of equality. I totally do not mind it if you abbreviate it like I've done here. Don't go much less than that. Okay, don't just say add. That's probably a little too little. And be careful when you do subtraction. Make sure you put the T on there because there's going to be another property we'll talk about tomorrow called substitution, and you can mix those up. So, put it SUBT and then we'll do substitution SUBS. I think that should be clear enough. The commutative property just says that if you have things that are being multiplied or added together and you change the order of those things, it's still, like if you had an equation before and you change the order, it's still going to be, sorry, let me try to say that again. Let's say I've got A plus B and I switch the order. A plus B is the same as B plus A. The associative property says that you're associating different things in different orders. So if you had three things, 1 times 2 times 3. Well, normally in the just order of operations, you do whatever's on the left, so 1 times 2. And then secondly, you would multiply by 3. Well, we could also group it, keep the same order, 1 times 2 times 3, but this time we're going to associate 2 and 3 together first, and then we'll multiply 1. And you end up with the same exact thing. And the last one is the distributive property, which you've done a lot in algebra. If you have something multiplying a set of things inside parentheses, you're distributing the thing outside the parentheses to everybody inside the parentheses. 2 times parentheses x plus 1 equals 2x plus 2. Okay? The last one is the symmetric property, which just simply says that if x equals y, then y equals x. Think of symmetry, mirror images of each other. So we're going to do a simple proof, and I'm going to show you the steps that I'm concerned about, and we'll just kind of go through this, and we'll just kind of, again, just dip our toe in the water, okay? So if I said given, see, all proofs, they're going to give you something. So I'm going to say 2x plus 3 equals 9. You are going to prove that 3 equals x. So take a gander at that. Now, if I just gave you this equation, I said solve that equation. With your algebra mind, you would very quickly be able to figure out what x is. But with your writing a proof mind, we are going to break that down into individual steps. Every step that you would do, and some of those I know you would just do in your head. But we're going to show every individual step, and we're going to give a reason why for that step. That's how you write a proof. Now, there's different types of proofs. Your book talks about a lot of them. The classic one is called the 2-column proof, and that's what we're going to stick with. You don't have to learn any more than that. So you're going to write 2 columns. On the left-hand side are going to be your statements. and you write it up there, although I personally don't mind if you just write an S. Okay, but you should know that the S stands for statements. The right-hand side is going to be your reasons. And likewise, I don't mind if you abbreviate that R. You are always going to write what they give you. And you're going to number your statements. So statement number 1, we're just going to write what they give us. 2x plus 3 equals 9. And the reason for that is, you don't have to think very hard. The reason for that is because they already gave it to you. So you just write given. That's what you're always going to start off with. If they give you 2 things in the given, or 3 or 4, you're going to write those down. Number them 1, 2, 3, 4. The reason why we number them is because that's going to come in handy later. But for right now, just number them, okay? Just trust me. I'm going to erase this so I have a little bit more room. And so think about that. What would be your first step in solving this equation? Well, you know that you're going to get rid of that 3. You want to get the x's on one side and the numbers on the other. First thing you're going to do, you're not going to undo the multiplication. You're going to undo the addition first. So we're going to rewrite it. 2x plus 3. And the way that we get rid of 3 is we subtract 3 from both sides. I know you learned how to do that. And again, I know that sometimes you skip those steps because you do them in your mind, but here we're breaking them out. We are not skipping anything. Now your reason for that, look over here. Why can you subtract the same thing from both sides and still have it be an equation? Well, that's the subtraction property. Okay? Next step, step 3. You know that 3 minus 3 goes away, 9 minus 3 turns into 6. So we can rewrite this as 2x equals 6. And the reason why, you can just write simplify. Now, last step, we want to get rid of the 2. We want to divide both sides by 2. So we have 2x divided by 2 equals 6 divided by 2. The reason why we can divide both sides by 2, of course, is the division property. I hope that's neat enough that you can see that. Step 5. You can guess what's coming next. We're going to simplify. And we end up getting x equals 3. The reason why is simplify. Now, I should have pointed this out at the beginning. After you write the given, some teachers tell you to automatically put what you're going to prove down here. I don't really like that because, for one thing, it's far away. And the other reason is you don't know how many steps are going to come in between. So what I do is I kind of like circling it right away. Then when I have the given, I look at where I'm going. It's like my road map. I'm trying to turn this and transform it into that. So you don't want to just launch in here without looking where you're going. Now I have proven that x equals 3. What did they want me to prove? They wanted me to prove that 3 equals x. So I'm not quite done yet. There's one more step. As picky as this sounds, I know that you would probably argue with me and you would say, Mr. Richard, we know that 3 equals x is the same as x equals 3, but you don't unless there's a reason. That's what I'm trying to get through to you. There has to be a mathematical reason why that's the same thing. It's not just the same just because God made it that way. So we are going to take this and we are going to flip it around. And the reason why you can do that is because of this property, the symmetric property. And now that we have what we wanted to prove, what we started with, and reasons for everything, we're good. Okay? So there's your first proof. Hope it felt good. Do you see what I mean about being logical, orderly, step by step? This is good training for your brain. Every time we do one of these, you should just go, ah, yeah. It's just as good as when you do like 10 reps and you feel that pump in your muscles, you should feel that pump in your brain, okay? All right, tomorrow we're going to do just one baby step more than this, okay?